The largest satellite of Jupiter, Ganymede, and also the largest satellite in the solar system, would have an amount of water 30 times greater than all the oceans on Earth. Candidates for this would be Saturn's satellites Europa and Enceladus, each of which is estimated to hide an interior water ocean over 10 kilometers thick. The following year, ESA planned the mission JUICE to send a probe to investigate the interior of the Jovian satellites, confirming or denying this. JUICE will spend at least 3 years conducting detailed observations of the gas planet Jupiter and in-depth studies of its 3 largest natural moons, moons on which oceans may be found, namely Ganymede, Europa and Callisto. The satellite will have a mass of about 6 tons at launch and will be placed around the Earth in an escape orbit towards Jupiter to begin a journey of 600 million kilometers. After a 7.5-year journey in which the spacecraft will use flybys of Earth, Venus and Mars, it will enter the orbit of the giant planet in October 2029. The tour of Jupiter will include several flybys of the main planet-sized satellite and will conclude with the entry into orbit of Ganymede, the largest moon in the solar system. JUICE will carry the most complex scientific equipment ever to travel to the solar system. These consist of 10 state-of-the-art instruments plus a science experiment that uses the ship's telecommunications system using ground-based radio telescopes. The JUICE instruments will allow researchers to compare these icy satellites and investigate the possibility that such bodies may have environments that could support life, such as oceans beneath the planet's surface. At the same time, the instruments will make observations of the planet Jupiter, its atmosphere and magnetosphere, other satellites and rings. The JUICE ship is developed and built by Airbus Defence and Space. As prime contractor for the design, development, production and testing of the satellite, Airbus will lead a consortium of more than 80 companies covering more than 110 contracts. Resistance to the extremely strong radiation to which it will be subjected during the sales mission is not one of the criteria that the JUICE mission has to fulfill during the preparation period. Components and materials must be carefully tested and selected, and anti-radiation shields must be developed. Some components of the JUICE mission will be tested in Romania against space radiation. The team of the Leopard Competence Center, funded by the STAR Research, Development and Innovation Program, Space Technology and Advanced Research, contributes to the development of radiation testing methods for mission hardware and software components spatial. In particular, with regard to the JUICE mission, the center is developing an electronic equipment testing infrastructure.